My name is Ashish Kumar. I'm Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. And my today's subject is operating system and subject code is BCS 401. My topic is disk structure. In this topic, I have to discuss about the structure of disk, working of disk, or types of disk scheduling, algorithms, and RAID. Disk structure. Basically, disk form of this way. Suppose basically, if any disk basically form a different tracks and different sectors and different heads files, and basically this is the pictures of the any disk as a form of plastic coated with the magnetized materials. Okay. Basically, you know that initially level different discs are available in market as a secondary hard disk secondary device, and in the disk basically two surface, inner surface or outer surface, and it is this disk is called a platters. Here mentioned platter, and platter in this way, and direction of basically this is the direction of heads. One head is upper direction and another is lower direction. It is moved from forward and backward direction. Basically it is a provide the data from which location are data storage. Basically data storage as a disk as a track or as a sector forms. Here mentioned structure, several disks are stacked to be spindle, one below the other with read-write head to make a disk pack. Information are stored on the surface of disk along concentric set of ring called track. These track are divided into section called sector. That means we say that in a disk number of tracks are given and every tracks concern number of sectors. Sector are available in every stacks. So move on next slide. Basically physical characteristics of disk is head motion. Head motion, that means fixed head, one per track. One head is fixed. You already see on these pictures. This is the head, and head fixed on the tracks and move forward and backward direction. Fixed head, one per track. Movable head, one per surface. Sides, single sided or double sided. Single is the upper surface and niche is the double sided. And disk portability, non-removable disk, hard disk, removable disk, floppy disk. All of you know that what is a floppy disk and what is the non-removable disk. It is single sided, double sided, already platter, single platter, multiple platter. Multiple platter, different platters are used in this figures. Working of disk. When a disk drive is operating, the disk is rotating at constant speed to read write. The head must be positioned at the desired track and at the beginning of the desired sector on that track. Address bits specifies the disk number, the disk surface, the sector number and the track within the surface information. Transfer is very fast once the beginning of a sector has been reached. Disk performance parameter. Basically disk performance are increasing through the seek time. The time is take to position the head at the desired track is known as a seek time. That means move on the again backward slash in this slides. Every track consider sectors, and in the sectors a data is available. A head movements through the head movements we have to move on the reach the final data in a tracks. Then movements of head is minimum. Minimum or maximum, that time is called a seek time. Rotational delay, rotational latency, that means once the track is selected, the disk controller waits until the appropriate sectors rotates to the reach under the head. The time it takes for the beginning of the sector to reach the head is known as the rotational delay or rotational latency. Next, disk performance parameter. Basically it is a performance parameter. First is already I have to discuss, it is also a performance parameter or totally disk or dependent of this parameters. First is seek time, next is rotational delay, third is access time. Access time, what is access time? The time required to reach the desired location and obtain to contain is called the access time. That is sum of seek time and rotational delay equal to the access time. Transfer time, the time data transfer from the referred as the transfer times. Introduction part. Whenever process need IO2 or perform the disk, it issues a system calls to the operating system. If the desired disk drives and controller available, the request can be serviced immediately. If the drive control is busy, any new request for services will placed in the queue or queue of pending requests for that drive. For a multi-programming system with many processes, the disk queue may often have several pending requests. Thus, when one request is completed, the operating system chooses which pending request to services next by using the following disk scheduling algorithm. Basically, some disk scheduling algorithm are introduced through the disk scheduling process. First is FCFS, that means first come and first serve. Those tasks are those requests are enter first. Suppose we request the given the position for and request for the data, that is first entertain. Then process request sequentially fair to all process approaches random scheduling in performance if there are many process. First come first serve, that means first task is introduced, then give the first solutions in through the FCFS. Okay, how to solve the FCFS problem? In this question basically given the okay, in that question basically given some value 98, 93. This is the basically sector value. Sector value, that means a number of tracks are available in a disk, and every track are cover the different tracks, and different sectors, and every sectors can collect the data, different data, store the different data, and that whole the 98 is the basically position of the sector. In a 98 position, a different data is available, and asking the first example through this question, in a 98 position, requirement of 98 position data, and OT 3 position of data, 37 position of data. So that is a given different location of data finding. So through the FCFS, basically through the FCFS finding the seek time, basically head movements, finding the head movements, and head movements it is also called the seek times. So initial position in this question, initial position of head movements is 53, and it is moved from the next position. First data is movement is 98. That means suppose first position is 53. Head is initially head position is 53 position, and asking the data, first data asking from the 98 number sectors. So movement of head from 53 position to move on head on 98 position, and collect data from and collect the time taken from 98 to 93. So here already mentioned. That means first data I have to find. First data I have to find from FCFS, because first request is 98. Another request is 183. So my disk, my head is which position? That means 98 position my head is stored. So head move again 183 position. So you have to find the next 183 position data. So next head movement is 98 minus 198. And again 182.3. Ab next head position is 183, and data required from 37 position. So head move on 37 position. That means head movement 183 minus 37. Okay. Again next 122. 37 to movement is 122 next position. Then head movement is this. Next 122, 14, 14, and then position 122, 14. Next 120, 14, then 14 to 124, 14 to 124, 14 here, and 124 is there. And next 124 to 65, 124 to 65, and then value is 65 location, and then 65 to 67, 67 and 67. After calculation, we have to find the total head moments, and it is also called the sick time. So through this process in FCFS condition, we have to find the solution of this problem. Next is shortest sick time first. Shortest sick time thus, those if head value is 50 and different position, we are asked the question, asked the data from different position. So if head movement minimum from one position to another position, that jobs first entertain. In that condition, SSTF condition, that jobs first entertain, those value is minimum from head to desired location. It is called the shortest sick time first. Here mention also, shortest sick time, select the request within a minimum sick time from the current head position. SSTF scheduling is a form of SGF scheduling, may cause starvation of some request. Okay, next. Shortest sick time first is completed. Next scan is no shortest sick time, not shortest sick time. This is an example of shortest sick time first. It is a given the question 98, 183, 37, 122, 14, 124, 65, 67. Exam point of view, this scheduling is most important. Maximum time I have to see that in a university papers, through this scheduling section, number of question are maximum, around 7 marks, 10 marks of question every time asking the university question paper. So here given the some values that means some sector values where data is available, and requesting of data through that position. And in this question, basically I have to use the shortest sick time first. So my head position is initially 53. So you have to check from 53 position to near about location where data is available. So 53 near is basically I have to check through this form. 52 basically near is 65, because 53 minus 65 what? So that means 5 minus 3 2 and 6 minus 5 12. So minimum that means only 12 track move we have to move on the desired location. So it is the minimum track movements. So 53 to 65. Again 65 to near track is 67. Again 67 to near track is 37. 37 to near 14. So near. Next who are near? First we have to find out. Then you movement from head from that location to another location. Okay. Then we have to finding from this previous way of head movements, and that is your calculation. Finding the calculation is 236. It is a final answer of your question through the SSTF shortest sick time first. Next is scan disk scheduling. In a scan disk scheduling, basically maximum time you have to give the direction of movement of given in an exam. Okay, which direction you have to move? If you move on forward direction, then you have to move the last position. Then you back from entertain every track needed track where data is available, and entertain and collect the data, and finding the total head movements in this way. You have to see the example through the direct move on this. Suppose same question, same example up here you using. So again, 53 position. This is a move on backward direction. So in backward direction, all of you see that in this slide, in a backward direction, you will move on the last position. Last position. Then you have to enter one by one, one by one, one by one, one by one, another process. Then again, we have to finding the in this way, we have to head movement and the result you find. C scan, circular scan condition. Circular scan, condition basically move on the last position, then move on again last initial position, and then entertain the values one by one. In this way, first move on the last position, then suppose in this way, suppose not given clearly through another not clear through this example. Basically, I have to through this example I have to clear that. Basically, in C scan, circular scan, in case of scan, which direction, if move on backward or forward direction, move on last position, but not move on the initial another backward position and last position, just you have to enter the given track. But in circular scan, it is a totally different. In a circular scan case, we have to move on the last position and again move on the last position of the track. If track value is given 119, that means 0 to 199. So position is moved from 0 to 199. Then you have to enter tracks one by one. Okay. Looks. In look condition, no move on the last position. Just we have to enter the values one by one and direction you are given, and then you have to finding the values. So you have to see some theory. Both scan and C scan move the disk from arm across the full width of the disk. In practice, neither algorithm is often implemented in this way. More commonly, the arm goes only as the final request in each direction. Then it reverse direction immediately without going all the way to the end of the disk. Remember, scan just do not traverse till the extreme end. See, look, as it again we have to move in that direction, not move the last position, just we have to move on the second line position, and you have to enter all values in this way. So same as you mentioned, both scan and C scan move the disk arm across the full width of the disk. In practice, neither algorithm is often implemented this way. More commonly, the arms goes only as far as the final request in each direction. Then it reverses direction immediately without going all the way to the end of the disk. Here given some example as it is, you find the direction. Okay. So again, a different example are here given. So you see that these slides, as it is, I have to solve because already I have to give the theory regarding FCFS. In FCFS, first come first serve. Initial position of head is 15. Asking the first track and first sector data required is 4th position. So the 4th position I have to read the data. So head movement from 15th position to 4th position, 15th position, 4th position, and then find you data. Again in this way, every sector we have to find the data 40, 80, 11, 35, 7, 14, and we have to solve the problem. Again SSTF, again looks, okay. Looks first initially have to given the looks on. In a condition of look, basically in look condition, just you have solved this problem through the look. A disk drive, what question is asking here first. A disk drive has 50 cylinder, numbers 0 to 49. The drive is currently servicing at cylinder 15 and the previous request was at cylinder 9. The queue of pending request in FIFO order is 4, 40, 11, 35, 7, 15. Okay. We have solved this problem. Basically, most of time, read, scan. First, we have to difference. First, you have to create the difference between scan and look. In a scan, we have to see that if direction given, if right direction or left direction, then you have to move on in which direction given, then you have to move the last position in a scan case. But in look, just only required data, then I have to move from, this is suppose 40 data required, not 49, though not move on the 49 position, and another movement from backward for requirement of the data. So through this way we have to solve the problem. And another questions is RAID. What is the RAID? RAID basically redundant array of independent disk. Most time, okay, we have to discuss from the RAID, but most of time you have seen in exam asking the question regarding the disk scheduling, what is the disk structures in this form. Okay. So basically next topic is RAID. The idea was first given by David Peterson and Gibson of University of California, Berkeley in 1998. Redundant array of independent disk. Matlab independent disk. That means different disks are created, and that is not dependency of one disk to another disk, because data security, number of companies are use these platforms. The idea was first given by David Peterson and Gibson at the University of California at Berkeley in 1998. The basic idea behind RAID is to be combine multiple small inexpensive disk drives into an array to equalize performance or redundancy goal not attainable with one large and expensive drive. Consists of 7 levels 0 through 6 of RAID. Okay. So basically it is a collection of a small drive packet of RAID and appears as single logical storage units. That means different disks are combined, and basically it is the form of the single logical units. So here basically introduce RAID 0. RAID 0, the data to be stored is divided into number of parts called strips, and we load these strips across the number of disks of the array. Basically in RAID 0, basically a data divided, suppose a data given A, and A is divided different section. Suppose A is divided A1, A2, A3, A4, A5, A6, A7 and A8. Okay, different parts. So through this RAID 0, basically security of data is increases, and our data basically data loss is also minimized. So here mentioned already, the data to be stored is divided into number of parts called strips, and we load these strips across the member of disk of the array. So defined data is divided in different parts, and different disks are data basically stored. Through this process, data basically loss of data is decreases, and data availability, because if one disk is corrupt, another disk are working, so maximum number of data is available, so my work is not affected, and throughput are increasing. From this way, basically all work basically depends upon your data availability. Next, RAID 1. RAID 1 basically, in a RAID 1 condition, basically we have to create a copy from data. If data is stored in disk 1 and another disk, we have to basically create a copy. Okay, and so disk 2 basically a copy of the disk 1 mirror image. So here mentioned already, block mirrored, no strip, no priority of the data. Okay, and I have to discuss another part is RAID 2. RAID 2 and RAID 2, RAID 3, RAID 4, RAID 5 and RAID 6, RAID 7 in different way. I have to discuss in another lecture regarding from RAID 1, RAID 2 and RAID 3. So that lecture has my here completed. So